Welcome to Study Loop.
Velocity of the boxes at point B is VB, and velocity of boxes at point B equals 0. The kinetic coefficient of friction between the boxes and the surface is mu k, and mu k equals 0.4. Mu k is the coefficient of kinetic friction, and the incline angle with the horizontal theta equals 15 degrees. Distance from point A to point B is equal to 20 feet. So D equals 20 feet. Now we do part A of the problem. The work done from point A to point B is the sum of the work done by the horizontal component of weight and the friction force. Therefore, work done from point A to point B equals mgd sine theta minus force from point A to B times d, and this is equal to mgd sine theta minus mu times the normal force times d. D is the displacement, and further we know that normal force equals weight times cosine of theta, and therefore work done from point A to point B becomes mgd into sine theta minus mu cosine theta. Now we apply work energy principle. According to work energy principle, kinetic energy at point A plus work done from point A to point B is equal to kinetic energy at point B. And kinetic energy at point A is half mv naught square, and work done from point A to point B is mgd into sine theta minus mu cosine theta, and then this term equals the sum of this kinetic energy and work done from point A to point B equals 0. Now let's solve for V naught. Now we solve for V naught. So V naught equals root minus 2 gd into sine theta minus mu into cosine of theta. Now let's plug in values. By plugging values, V naught equals root minus 2 into g. G is acceleration due to gravity, which is 32.2, and then d is 20, and then sine 15 degrees minus mu is 0.4 into cosine of 15 degrees, and so V naught equals 2.817 feet per second. So V naught equals 12.817 feet per second.